Massive stars. They are some of the biggest and shortest living stars in our entire galaxy. These stars have masses of 8 to 40 times that of our Sun, with hydrogen-burning lifespans of several million years. The question is, however, what happens to these massive stars at the end of their lifespans? The final stages of a star's life starts after its hydrogen fuel is exhausted. For our Sun, it won't happen for another 5 billion years. However, for more massive stars, their size requires fuel to burn at faster rates, with the biggest among them only living for a few million years. Once the hydrogen is depleted, the core contracts and the hydrogen begins fusing into a helium shell around it. It is after this shell is formed, the helium shell begins to burn, and the star begins to expand as it starts to find its new equilibrium. Due to this expansion, the outer layers begin to cool, and the star becomes known as a red giant. And in the case of our massive stars, they become known as red supergiants. At this point in a massive star's lifetime, their size has increased up to several hundred times its original, and the core is starting to burn hotter than ever. Their surface temperature, however, cools to around 3,500 to 4,000 Kelvin, causing their colors to shift from blue to yellow to red. A red supergiant's mass can be anywhere in between 10 to 40 solar masses. Due to its size and helium fuel source, a supergiant's lifespan ranges from 3 to 100 million years depending on its initial mass. Towards the end of the red supergiant's lifespan, the core will become hot enough for helium to fuse into carbon, while still converting hydrogen into a helium shell. At the same time, the star will become unstable and start to pulse as it nears the end of its life. During the star's final stages of life, lasting for about 10,000 years, the red supergiant begins multi-shell burning, a process that begins fusing many elements into heavier and heavier elements, from neon and magnesium to silicon, eventually reaching iron. Iron is the dead stop element for nuclear burning, and after about a day, energy is no longer released by the core, and it can no longer equalize the outside pressures. This causes everything to collapse onto the iron core, eventually exploding into a Type II supernova. During this collapse and supernova explosion, everything afterwards depends upon how high the mass of the original star was. Since the range of high-mass stars span from 80 to 40 solar masses, there are 3 different outcomes. A lower mass star's iron core will go through the violent supernova and will leave behind the remnants of its core, becoming a neutron star, an abnormal object that spins very fast and produces jets of energy. A higher mass star's core will remain after the supernova, and due to its high density, it will continue collapsing onto itself, eventually leaving a black hole in its place, an object with such strong gravity, light can't escape it. Finally, if a core of a supergiant is unstable, it will explode with the supernova, and all the material will be thrown outwards into space, leaving a supernova remnant behind. These new celestial objects are the products of high-mass stars, and they will live in our universe for millions, if not billions, of years.